The GPU compute market is exploding, but most buyers are making a critical mistake. They're treating it like a simple commodity transaction. Buying AI infrastructure isn't like buying standard cloud storage. If you default to your legacy cloud provider out of pure habit, you could easily end up paying a 40% premium on raw compute costs just for the privilege of staying in their ecosystem. On the flip side, if you chase the absolute cheapest hourly developer rates to run a massive model, you'll likely starve that model of network bandwidth and ruin a multi-million-dollar training run. To avoid those extremes, we need to map this market. The AI infrastructure landscape has separated into 4 distinct tiers based on 2 variables: the scale of raw compute power you need and the depth of ecosystem you require. Those variables divide providers into legacy hyperscalers, the aggressive fourth hyperscaler, specialized neoclouds, and developer-first platforms. Avoiding multi-million-dollar inefficiencies requires dropping the best provider mindset and adopting a constraint-first framework to match the tier to your exact workload. First, establish hard constraints like data residency and compliance. If your data falls under strict EU sovereignty laws, US neoclouds are off the table. You're routed to European specialists. Similarly, requiring FedRAMP High authorization locks you out of developer platforms, mandating expensive legacy hyperscalers. Your legal and regulatory requirements set a hard ceiling on your infrastructure choices. Raw cost comparisons mean nothing if a provider fails your required audit. Once you clear legal constraints, the second branch is architectural. Are you training a foundation model or running production inference? Training a multi-node foundation model is a major engineering milestone. It requires continuous, heavy data communication between hundreds or thousands of chips working in parallel. Standard network cables will bottleneck that data flow. Training demands premium InfiniBand interconnects to prevent GPUs from sitting idle, wasting your compute spend. Inference is different. It's the continuous operation of serving the model. Because you have to keep model replicas worn in GPU memory constantly to avoid slow loading times, it becomes a predictable, recurring operational expense. This chart shows the projected distribution of GPU workload spend over time. You can see the orange section, inference, steadily expanding, forecast to consume 78% of all AI budgets by 2030, while training shrinks to a minority share. Purchasing a training-optimized cluster for an inference workload is the fastest way to burn through an AI budget without seeing a return on that investment. Now we can evaluate the actual providers, starting at Tier 1, the legacy hyperscalers. Their core advantage is data gravity. If your enterprise data lakes already live in AWS, Azure, or Google Cloud, keeping AI workloads right next to them avoids massive data egress fees. The trade-off is price. You will pay the highest per GPU hourly rates on the market because you are subsidizing their massive enterprise software integrations. Next is Tier 2, the fourth hyperscaler, specifically Oracle OCI, defined by aggressive capital deployment and massive anchor contracts. They compete by offering bare metal architecture. You get direct hardware access for massive cluster deployments, trading away the richer developer ecosystems found in Tier 1. Tier 3 introduces the GPU-native neoclouds, which specialize entirely in raw, pure-play AI infrastructure. Their value proposition is straightforward. They provide world-class InfiniBand networks for large-scale training runs at rates that can be up to 40% cheaper than hyperscalers. But that discount comes with a warning. Lacking generalized enterprise tools, their debt-leveraged business models rely entirely on high utilization rates to stay solvent. Finally, we have Tier 4, built for transparent, hourly prototyping and cheap model fine-tuning with zero long-term commitments. They are unmatched for agility, but have a hard architectural ceiling. Attempting frontier multi-node training on consumer-grade networking will functionally break the workload. Stop comparing raw costs. Use a constraint-based scorecard. Regulated enterprises must accept the Tier 1 tax to ensure FedRAMP compliance. Frontier AI labs need bare metal InfiniBand in Tiers 2 or 3. Bootstrapped startups should exploit Tier 4's zero-commitment hourly flexibility. Always keep your long-term timeline in mind. With 78% of AI spend shifting toward persistent inference by 2030, Your infrastructure decisions must be built for true long-term operational efficiency and not just a single isolated training run. Ultimately, infrastructure value depends entirely on how well your tier aligns with your specific organizational constraints.